Hi students, in the previous video I just talked with your karma map of your full adder. So we derived with your sum expression and with your carry out expression over here. So still further you can reduce your logical expression of your sum term. Look at this, over here you have four product terms. Look at the product terms which involves your NOT gate. So you have to, while this implementing the circuit, you need a NOT gate IC7404, and that too of how many? Look at this, 1, 2 and yes. So you will be consuming two NOT gates in your IC7404, and you need 4 AND gates and 2 OR gates. So I thought of why can't we still further reduce the expression. So it is also, when we look at it, we can reduce it. Take out the common terms, simplify it, and thereafter you will be obtaining a simplified expression. Sum is equal to A XOR B XOR Cn. So how we did, this is the steps which I have explained already in your theory class. Okay. So we have to take out A bar common over here, and among these two terms A common. So this will look like your B XOR Cn and B XOR Cn, which could be rewritten as inversion of your XOR. So I have rewritten the same expression in this step, and when we look at this, it will look like X bar Y X Y bar, which is nothing but you can rewrite it as X XOR of Y. So the same I applied over this expression, and you have it to be simplified as A XOR B XOR Cn. So the same for the sum circuit, so you can just draw it. If it's a 2-input XOR IC, if you are going to choose now, 2 times you have to draw it like this. If you are going to have a 3-input input pin IC XOR IC, then you can straight away have 1 XOR gate. So since in our laboratory we have IC7486, which is of 2-input pin IC. So I am going for step by step. So first, for this you will have 1 IC, XOR IC. For these two, the output of these two should be given to this, and you will have sum to be produced. And what is your C out carry out expression? You need 3 product terms, and it should be summed with the help of your IC7432. Okay? And this is the circuit diagram of your simplified circuit diagram of your full adder circuit, which we will see in the digital trainer kit to be implemented like this. So look at this. To make it short, I have already given the connection. Here you have your IC7486 and you have your 808, IC7408, that is your AND gate, and this is your IC7432, which is your OR gate. So as per the expressions, as I have told you already, so these ICs you are aware of it, IC7486 and IC7408. So similarly, the same way your IC7432 will also look like. So same way, pin 1, 2, 4, 5, 12, 13, 9, 10 would be inputs, and 11, 8, 3 and 6 would be your output pins. Okay. So how many other gates we need? So those many gates has to be picked in. So based on this, we have made use of 1, 2, 3 as output. From the output of third pin, next slot of 4, 5, 6 would be given. Similarly 1, 2, 3 and the next set of 4, 5, 6. So these two are clubbed together and we will have the or first pin and second pin and third pin. So this is how the connection I have made, and all your ICs VCC and ground are tapped together from one another, and the final connection is given to the power supply, which is of 5 volts, and the ground I have taken it commonly over here, and from there I have tapped it for all the ICs, and finally we will have the output sum and carry. Look at this, when all are 0, my output is 0, 0. When I have one of my input to be high, my sum is high and carry is low. And similarly for other case, similarly for the other. Just to check with one input, when all are high, both my sum and carry out is high. For few cases I have checked it. So similarly, you can verify your truth table. Thank you.